Hello and welcome to the Actuarial Rasta channel, the channel where we break down actuarial exam questions so that you can answer them accurately and on time. In this series of videos, we are still working through the 2026 April exam questions, and in today's video, we are going to work through question number 4, which tests on two topics: the characteristics of derivative securities and the binomial model. So, question number 4: an undividend paying stock has a current price of 95. Every 6 months, this is to note 6 months, the stock price either increases by 25 or 20 or decreases by 20%. The risk-free force of interest, this is also to note, force of interest, meaning it's continuous and discrete, is 3% per annum. Calculate using a two-period binomial model the price of a 1-year American put option. So it's an American put option. American meaning it can be exercised at any time and we do not have to wait for maturity. And a put option is also important to note. Calculate using a two-period binomial model the price of a 1-year American put option on the stock with a strike price of 100. So from this question, even before starting to answer, there are some formulas that can give us marks, and one of them is the synthetic probability of an up movement or a down movement. So the numerator is exponential RT minus down, the denominator is up minus D. The other one that can give us marks is the put option payoff, which is a maximum of the strike price less the value of the stock at time t or 0. Correct. So from there, I'll just write the basic information that I've been given in the question to help me calculate. So the up movement, it can either increase by 25%, so the up is 1.25, or decrease by 0.2, so down is 0.8. The other thing I've been given is the risk-free rate of interest, which is 3%. I've also been given time, which is 0.5. What other information have I been given? I've been given the strike price K, which is 100. Correct. So from this, the first thing that could give me marks is getting the synthetic probability of an up and down movement. So Q, as just from this formula, the numerator is exponential of the risk-free rate of interest and time less the down movement, which is 0.8, and then here it will be up minus down, and of course the synthetic probability of a down movement will be 1 minus Q, which is 1 minus 0.478. Good. Another thing I know I will have to use is the discounting factor. So I'll just write discounting factor there. That will be the exponential of, since I am discounting, it will be minus the time multiplied by the risk-free rate of interest. I know I'll have to use that somewhere. Okay, so at again, as I had highlighted here, it's an American option, meaning it can be exercised at any time at either time 0, time 0.5, or time 1. So we'll start where we are waiting for maturity, which is time 1, to exercise it. This will be the same as an European put option, since we are waiting for the very end. So we're starting at 95. When it increases by, or rather at time 0.5, and it can go up by 1.25 or down by 0.8. At time 1, it can either go up by 1.25 or reduce by 0.8. The same way 96 can either go up by 1.25 or go down by 0.8. Okay, so here we'll have to exercise it at maturity, and when we are exercising it, we are using the payoff of the put option, which we have the formula here. Max of k is 100. I'll just lock that so that I am able to copy and paste. Correct. So the value of the option for C up is 0, and then We've also calculated for CDD and then for CUD and CDU. So this is the value of the option if we wait till maturity to exercise. Then we also have to look at time 0.5. We had mentioned that this is an American option and not a put option, and we know that an American option can be exercised at any time. So we'll have to investigate at time 1, at time 0.5, and at time 0 itself. So at time 0.5, it can either go up by 1.25 or go down by 0.8. If we exercise at this point, the payoff will be the max of 100 less the value of the stock at time 1 or time 0.5. Sorry, I'll just lock this. That's what you get, and then do the same for here. So this is if we exercise. If we do not exercise, the value of the option will be the discounted values of the discounted values from time 1, which is again why we had calculated the discounting factor here. So it will be, this is also where we will use these synthetic probabilities. So the first option will be 0. This is CUU multiplied by the synthetic probability of up, or CUD multiplied by the synthetic probability of down, and then I'll discount. We have our discounting factor here, and then for the CUD, or sorry, for the CD, if we do not exercise, it will be the discounted values from time 1. In our case, it's a 5 multiplied by the synthetic probability of up plus that 9.2 multiplied by synthetic probability of down multiplied by the discounting factor. Good. So of course, when we are looking at our options, we want to get the one that maximizes value for us. So here we'll get either the maximum of either if we exercise or do not exercise. In this case, the best option is not to exercise, and in this other case, the best option will be to exercise the American put. Good. So here these are the values, the payoffs at time 0.5. As we had mentioned earlier, this is an American put option, so we also have to investigate at time 0. So at time 0, it's 95. If we exercise, the value will be the payoff is maximum of K, which is 100 minus ST, which ST now is S0. This is or 0. We get that. So if we exercise, the value of the option at time 0 is 5. If we do not exercise, it will be the discounted value of the payoffs from time 0.5. So here it will be 2.57 multiplied by the synthetic probability of up plus 24 multiplied by the synthetic probability of down. And then we discount this, we multiply by the discounting factor. We get that if we do not exercise, the value of our option is 13.5. And of course, we are looking to maximize our payoff, so it's the maximum of if we exercise or do not exercise. And with that, we get our answer is 13.55, and with that we are able to calculate and finish question number 1. So I'll just copy this working, copy, come here and paste my answer in that table there. Yeah, and with that question gives me 8 marks. So question number 2, explain if it will be optimal for the holder of this option to exercise it if the value of the American option is higher than the value of the of a European put option. And in this case, we had noticed it here. Let me just highlight. We noticed that this 24 is, which is the value of exercising at time 0.5, is higher than the discounted value of the European put option. So at this point, it will be optimal to exercise. So I just written the answer here earlier. So yeah, exercise early when the value of the American option is higher than the European option at time 0.5, which download, you have to be very specific, time 0.5 download, this point here, the American option value is higher than the European option value, it is optimal to exercise at this time, and with that you get your 1 mark. And then the very last option is discuss the limitation of the binomial model. This is very textbook. You can find it in your co-reading notes, and this question has also been repeated several times in past papers. You can check out other videos that I've done to see how this how many times this question has appeared, and the answer is very simple. So in the binomial model assumes that stock prices only move one of two values in a single step. It can either go up or down, which is not true. In the real world, you're not only limited to two options. There are several other options. The binomial number two, the binomial model only models discrete steps. Discrete step changes in stock prices when real stock move continuously. So here you can see that the time is discrete. It's either 0, 0.5, or 1. While we know that in the real world stock move continuously, we're also assuming that there are no transaction costs, there's no taxation, and then the models assumptions can sometimes be very unrealistic, like assuming a constant interest rate and constant volatility, and then the real world these values change. The models also assumes that you can buy and sell at infinitely small amounts, and we know that stock prices only um, how they move. And the last one is usually model up to limited time horizons. If we were modeling up to say time 100, using this model wouldn't be very realistic. It would be very uh, cumbersome. And with that, we are able to get all our 3 marks. You can walk through this question. If you do several questions of this, you can walk through these questions really fast, and it will save you time to answer other questions. And with that, we have come to the end of the video. This is the Actuarial Rasta channel. Subscribe and join me as we tackle more actuarial exam questions together, and see you in the next video.